Hello, everyone. Today we'll be going over the simulations done on the combustion engine that we designed. We did this project between Isabella Monteviera, Valerie Carl, and myself, Owen Gill. Today I'll be guiding you through this presentation, and we'll get started by talking first on the conditions in which we did the engine. We did the conditions based on a typical motorcycle like the Honda Activa 6G, which is a very common motorcycle in India. And motorcycles like these experience a PSI, a compression uh, pressure of 150 PSI, which is about 1 million pascals. And then we use this value to find the force in different parts by looking into the cross-sectional area. We also took into account the heat flux, this part's experience, and also the convection value. Now, if we start with the design itself, we see that we're using a simple one piston design to easily look into the studies and analyze them. The first study that we did is on the piston head, where with the pressure um, that we're using, we see that the piston experiences a force of about 8,000 Newton and a max stress of about 8 million pascals. This leads the part to see the minimum factor safety 32, and displacement, a lot of displacement on the top, and a lot of this strain in the pin insertion. On the next part, we see that the piston pin experiences a graded force of 3,298 newtons, and now the stress is concentrated in the middle, where it sees about 8 million pascals, and the same factor safety 32. And a lot of the strain also happens in the middle, wherein the displacement happens in the middle, but in the lower part. And the crankshaft itself, in the vertical position, it experiences a force of 2,000 newtons and a max stress of about 1 million pascals, and a really high factor of safety, 180, where a lot of the strain and displacement is happening in the crank pig in the middle and the top part as well. So if the same crankshaft is analyzed but in a horizontal position, uh, this part encounters a torque of 70 Newton meters, a max stress of 2 million pascals, a lower minimum factor of safety 97, and a lot of the strain displacement happening to the right of the part. Now, if you look into the connecting rod, it sees a similar force of 1,000 newtons, greater stress of 3 million pascals, a minimum factor safety of 72. And now in this case, the displacement happens in the top, greater of the displacement happens on the top, while the strain happens in the middle section. And if we look further into the connecting rod, we see that the load factor changes by different modes, right? First, it starts with 107, and by the last mode, it ends with 866 with a lot of distortion. If we want to optimize this part by reducing the mass, reducing the stress, and maximizing the factor of safety, we see that we reduce the max stress from 3 million pascals to 2 million, and we increase this factor of safety to from 72 to 100. If we look into the thermal studies, we see that the max temperature that the piston head experiences 1,421 Kelvin, and a minimal temperature of 1,259 Kelvin. And it changes over time in increments 120 seconds, first by starting with 506 Kelvin and increasing to 99 Kelvin. With these studies, we'll be able to understand how engines like ours will experience parameters seen in real life motorcycles. Thank you for watching.